let's start the lecture. See on the screen that problem is check whether the following sets of functions are linearly independent or dependent on the real x-axis. The first set is, let us solve the first set. There are three functions fx is equal to 4, gx is equal to x square, and hx is equal to e to the power 2x. So we are given three functions. We have to verify that these sets of functions are linearly independent or dependent. So let us check this. Let us multiply this each function with component a1 fx plus a2 gx plus a3 hx is equal to 0. Now substituting this value of fx, gx and hx, we get a1 into 4 plus a2 into x square plus a3 into e to the power 2x is equal to 0. So we can see that this equation is satisfied only if values of a1, a2, a3 all are equal to 0 for any value of x. Now let us check keeping the values of x, different values of x. So if we are keeping the values of 1, so it becomes 4a1 plus a2 plus a3 into e to the power 2 is equal to 0. This is possible only when the a1, a2 and a3 are separately 0. Therefore, the given set of functions fx, gx, hx are linearly independent. Now let us check the second set of functions, that is fx is equal to x, gx is equal to x square, hx is equal to x cube. So to verify whether they are linearly independent or dependent, let us multiply each functions with their component. Suppose a1 fx plus a2 gx plus a3 hx is equal to 0. Putting the values of fx, gx and hx, we get a1 x plus a2 x square plus a3 x cube is equal to 0. Therefore, we see that for each and every values of, for any value of x, the equation a1x plus a2x plus a3x cube gives is equal to 0, gives a1 is equal to 0, a2 is equal to 0 and a3 is equal to 0. For example, let us take the values of different values of x. For example, x is equal to -1, 1 and 3. Then the equation becomes minus a1 plus a2 minus a3 is equal to 0 for x is equal to -1, a1 plus a2 plus a3 is equal to 0 for x is equal to 1, and for x is equal to 3 it becomes 3a1 plus 9a2 plus 27a3 is equal to 0 for x is equal to 3. So for we are having three equations for different values of x, and all these three equations are giving the values of a1 is equal to 0, a2 is equal to 0, a3 is equal to 0. Because you can see that addition of components of these equations will be 0 only when they separately becomes 0. Now let us solve the set C. In the set C, functions are given fx is equal to x, gx is equal to 5x, and hx is equal to x square. So from these three functions, we can see that we can write gx is equal to 5fx is equal to 5x, and hx is equal to fx whole square. So also we can further see that gx can be expressed in the terms of other two functions, like gx is equal to 5 fx plus 0 into hx. So we see that these three functions can be related to each other, and one of these functions can be expressed in terms of the other two. Therefore, these functions are not linearly independent, hence they are linearly dependent on each other. Next set of functions is fx is equal to 2 plus x square, gx is equal to 3 minus x plus 4x cube, and hx is equal to 2x plus 3x square minus 8x cube. Now let us check whether these three functions fx, gx and hx for these given values are linearly independent or not. So we can see that hx is equal to 3 into fx minus 2 into gx. Thus we see that the set of functions D is not linearly independent, but they are linearly dependent, as one of the function hx can be expressed in terms of the other two functions. Therefore, these three functions are linearly dependent. Now solve the another set of problems based on the linearly independent and dependent properties of the vectors. So let us see. So problem is, are the following sets of vectors in the three-dimensional Euclidean space linearly independent or dependent? So we have four problem in a single problem. So we'll check one by one for each set of problem. first problem is the three vectors are given. A is equal to 3, 0, 0. B is given 0, -2, 0. And C is equal to 0, 0, -1. Let us write in equation form by multiplying their corresponding components. So A1A plus A2B plus A3C is equal to 0, which further can be written as A1 A1 3I plus 0J plus 0K plus A2 0I minus 2J plus 0K plus A3 0I plus 0J minus K is equal to 0, which implies that 3A1I minus 2A2J minus A3K is equal to 0. So, which leads to 3A1 is equal to 0, 2A2 is equal to 0, and A3 is equal to 0. Therefore, A1 is equal to A2 is equal to A3 are 0. That is, this first set of vectors are linearly independent. Now check for the second. Vector A is given as 6I minus 9J plus 0K. B is given as minus 2I plus 3J plus 0K. Writing these two vectors in equation form, A1A plus A2B is equal to 0 gives 6A1 minus 2A2I plus minus 9A1 plus 3A2 into J is equal to 0, which further gives A1 is equal to minus 3A2. That is, first vector is equal to 3 times the second vector. That is, A is equal to minus 3B. Thus, we see that first vector can be expressed in terms of the second vector. Therefore, these two vectors are linearly dependent. Now, C part. So, vector A is given as 2I plus 3J minus K, and B is equal to 0I plus J plus 2K, and C is equal to 0I 0J minus 5K. So, writing these three vectors in the equation form, A1 A vector plus A2 B vector plus A3 C vector is equal to 0. So clearly we can say that 2 A1 I plus 3 A1 J minus A1 K plus A2 J plus 2 A2 K plus minus 5 A3 K is equal to 0. Arranging this, we get that 2A1 I plus 3A1 plus A2 J plus minus A1 plus 2A2 minus 5A3 into K is equal to 0. Therefore, we can write this equation as 2A1 is equal to 0, 3A1 plus A2 is equal to 0, and minus A1 plus 2A2 minus 5A3 is equal to 0. The solution of this system gives A1 is equal to 0, A2 is equal to 0, and A3 is equal to also 0. That is, the given three vector set is linearly independent. Now we'll check the fourth set. So A is given I minus 2j plus 3k and B is equal to minus 4 I plus j plus 7k and C is equal to 0 I plus 10j plus 11k and D also given is equal to 14 I plus 3j minus 4k. Let us solve this. A1A plus A2B plus A3C plus A4D is equal to 0. Now A1I minus 2A1J plus 3A1K minus 4A2I plus A2J plus 7A2K plus 10A3J plus 11A3K and 14A4I plus 3A4J and minus 4A4K. Arranging this equation gives A1 minus 4A2 plus 14A4I plus minus 2A1 plus A2 plus 10A3 plus 3A4J plus 3A1 plus 7A2 plus 11A3 and minus 4a4 k is equal to 0. This gives that a1 minus 4a2 plus 14a4 is equal to 0 minus 2a1 plus a2 plus 10a3 plus 3a4 is equal to 0 and 3a1 plus 7a2 plus 11a3 minus 4a4 is also equal to 0. Thus, we are having three equations and four variables. So, solving these equations, we get vector D is equal to 2a minus 3b plus c. So, we can see that the vector D can be expressed in terms of the other three vectors. Therefore, these four vectors are linearly dependent on each other. Hope you learned the techniques of solving the problem based on the linearly independent and linearly dependent vectors. If you like this video lecture, please press the like button and share with your friends and colleagues so they can also learn about these concepts. Friend, if you are watching for the first time, please subscribe the Sai Academy channel and press the bell icon so that you can get the notification of the upcoming videos on time. Thank you, friends.